What's going on, gang? We're picking back up in this tutorial. We had left off uh, finishing out all of our CRUD routes and at their simplest as they need to be in Postman and testing and all that kind of fun stuff. And we're finally ready to do the React side of things. Like I'm trying to keep all the fundamentals towards the beginning part of this playlist series. And then eventually when I start adding weird random features just for the sake of adding them and keeping this playlist and tutorial series ongoing, uh, people that were looking for the core stuff already kind of got it and maybe they phased out, or if you're just super interested, you're still following along. But we're still working on the fundamentals here, folks, and we're working on React today. It's actually been a hot minute since I've done React with TypeScript. I've built an entire standalone React course. Check the description below for a link to Covalence if you're interested in buying my React course. Covers everything from state management libraries beyond Redux into how React works and actually works at a theoretical level and all that kind of fun stuff. Deep dives into all your kind of hooks and custom hooks and stuff like that. Routing and routing options and yeah, it's like meant to take you from zero to hero in a short amount of time. So if you're interested, go comment, like, comment, subscribe, and check the description below. I can't talk, which is not good for recording a video. Anyway, we had left off with this application. The last time we actually looked at this React stuff, I'm fairly certain all we had, was a simple create root. We had this beautiful looking application that simply rendered a div and an h1 to the DOM here, which we can go take a look at. Not 300. Come on, man. Come on, man. And we got this is cool up and running without too much fuss. And I think we have our React dev tools ready to go. Cool. All right, so yeah, this is where we left off on our application, and honestly, in this video, we're not going to be adding a crap ton to it because we have some setup that we need to do. At the moment, I have a single-page application, which is what React is. We have an error? What is our error? So here's an error we got from the client side, which caused an error on our server, which is the get/favicon.ico not found. Favicons are these icons that you'll see websites have in their tabs and in your bookmark tabs here, right? They'll have various icons here that we don't have in our application. Hence, we won't see the error because I think I refreshed it. But all modern browsers are coded to look for one and request one. And because we don't have one, it ended up causing an error. But don't worry about it. We're gonna add one in the long run here. They're actually pretty easy if you know where to look or what to do. So we have our simple React application. It's a single page application, meaning it's just a singular index HTML. And we haven't touched it since I think the first video when I set up everything from scratch from a completely blank directory, which still blows my mind that we've gotten this far. So let's continue on this discussion. We're going to want to have routing because I want to have a page where I can add new notes, a page to view all my notes, and a page to view, and by page, I mean that in air quotes. Technically, it's one page. Again, there's a reason why I create React app and the way we built this thing is called an SPA or single page application. Technically, it's one index HTML page, and we're just viewing different parts of our JavaScript code when it comes to routing and React applications. So we actually need to install a library to help us do routing rather than rolling our own. This one, I'll pick React Router DOM. We're going to do React Router DOM. So we're going to do npm install react-router-dom, and it should install the newest version, which is v6 something or other. Yeah, cool. We got it installed. Good to go. Let's add... I don't know if it comes with its own types these days. Let's go find that out. Because in the past, you used to have to install separate typings, but it might come with its own types these days. Well, I didn't get this is a stub definition that's deprecated, so it looks like we have types added for React Router DOM successfully now. Let's get this sucker back up and running and start dealing with whatever new issues I'm about to add to my application. Because it's actually going to be a bit more complex than simply adding React Router DOM to something like Create React App, or if you're in Next.js, you already have like your routing stuff built in for you, which is kind of nice. We need to actually do a couple extra things when it comes to setting up routing in this particular style of application, meaning where we have written our own server that is serving our own public HTML and the associated JavaScript code with it, right? So what we're going to do is we need to first... we're going to set up some basic routes and some views here. So I'm going to make a new folder. We're going to call it views. Or maybe you can call it screens. I mean, you can call it pages if you want. I mean, you can call it pizza for all that I really care. I'm calling them views because technically that's more accurate to what it represents than pages. These are going to be the different views that a user could theoretically see across my application. So we'll have like a home view, right? We'll say import React from React. We're going to make our home component. Did I do types in my app TSX? I did. Yeah, so we're going to do the exact same thing we did back in the app.tsx way back in the day. Is just by making an empty interface to represent what kind of props are going to be passed in, because at the moment it is going to have none. Yeah, I should just copy this whole thing and just change the name app. Watch this, y'all. Watch this, folks. Boom, look at that magic. Basically, I'm building or scaffolding out like a little templatable component that I can copy and paste a couple of times here. Honestly, I might just make a template.tsx or stick this in the README as a template. Stick this in the README as a template that I can copy and paste from. We'll see. Yeah, so we're going to have a home page. We're going to have a login page to test our login and auth stuff with. So we'll call this the login component. Beautiful. We're going to need eventually a register page and whatnot, but we'll get there when we get there. For now, I'm going to call it private.tsx because this is going to be somewhere that you need to be logged in to view. The home page will be public for now. Yeah, this is a good setup. Like I'm basically setting up a couple of test views that I can mess with so I can start working on my auth, because that'll be kind of key to the whole thing working before we start fetching data and displaying it all. I want to make sure that someone can be rerouted away from a private page if need be, making sure they can log in, and we talk about how we're going to store that login, and it's not going to be through cookies. I want to keep it kind of simple for this series, like I'd alluded to back in the server coding, where we're just going to stick it in local storage and call it a day. But that does have its drawbacks, and it's not exactly the best solution. But again, I'm making this series assuming that you're coming in with some experience, some self-taught experience. Maybe you're a fresh bootcamp grad and you're trying to hone in all this stuff on the stack that we're using here. But yeah, we'll talk about that when we get there. And then some kind of public page they can view for free, but without having to be logged in and things like that. Practice some redirects and whatnot. So yeah, got a couple basic views going here. I'm going to choose to organize my exports under one index for a directory. So I'm going to say export default as home from the home component. Now, you'll notice here that my component names I've chosen to make capital letters. That's a common convention in React applications. Again, this could be lowercase pizza.tsx that exports a home component, but typically it's a good idea to name your files that have React components with capital letters by the same name that they are called, as their function is called ultimately. It's a good practice to do so for just a quick visual scan to know that these are component files that contain TSX code within, and not some kind of utility file that might run some business logic that are typically lowercase letters. There's a common convention you'll see across projects like that. And then me choosing to do this step right here will just give me some cleaner imports in the long run. You don't have to do it this way if you don't want to. I could just as easily go to my app right now and simply write import home from ./view/home and be fine. But I know in the long run, I like having cleaned up import statements. So what I'm going to choose to do instead is do some cool shenanigans with exports to give myself named imports under one set of curly braces when it comes time to actually bring these in. And what I mean by that is something we're about to see here in just a moment. I don't need to have the home, login, or private components opened at the moment because I want to set up my routing here. So I know of V6's changes, and I know there's even like a V6, like when it comes to React Router DOM, I know there's even more additional changes when it comes to how they want to render the application. Like they have a new, I think, called data API that has moved away from the traditional declarative approach that React Router DOM has taken, meaning writing down components that declare what the routes, the browser router, all that stuff is going to be. We're gonna follow that, and maybe in the future video switch to the create browser router function instead, which is like its version 1.8 or something like. I can't remember exactly what the version numbers are, but we're going to stick to the kind of more old school approach of how browser router or React Router DOM and browser router in particular work. So let's go ahead and do that. I'm going to say we're going to import from React Router DOM the core components needed to get routing going. Now we're going to choose the browser router because that's what we're doing here. We're just we're just building a simple set of routes that are going to be operating in a browser. We don't need any other crazy features like from a hash router or things like that. We're going to use browser router for this one. And we also need to import our routes component. This one is where all the logic lies for path matching and things like that. We're going to also import our route component, which will be setting up the individual route, their path, their children, and what element they're going to render. Okie dokie. So we need to now import the components I'm actually going to be rendering here. So I'll say import from my views directory. I would like to import now my home, my private, and my login components right there. Now, the way browser router and React Router DOM work is the browser router has to be sandwiching your entire application in order for it to do its job and for routes to get some kind of global context from. So we're going to have browser router be the sandwich bread of this sandwich here. So we're going to make sure that's the top level render that we have going on right now. From there, we're going to have our list of routes. This actually replaces the old switch component from v5, if you remember what that looks like. And here's where I can define my individual routes, where I'll say on the home path, I want you to render the home component like that. And let's go ahead and see. Let's just save. This should recompile, hopefully with no errors. I'm going to refresh the browser, and hopefully instead of this app is awesome or this is cool, it should say home. That's what I'm talking about. And as you can see, our render tree already got far more complex. So from there, I can now make the two other ones, which are going to be the login and the private path for testing purposes while I set up this auth stuff. There's that. There's that. And we're going to go test this here in the browser in just a moment. Why am I smiling? Because I know what's about to happen here. Like I've done this before. So we're going to go to the login page by going to our URL bar and writing /login, hitting enter, and looky at what we got. We did not get our component as we expected. We got an error that is very obviously the one that we wrote with our global error handler back in whatever video that was. This is a server-side error saying, hey, yo dog, I don't got no GET request called /login. Right? We have like post /auth login is a thing, but a GET request to the login endpoint is not. But you're like, wait a minute, this is a client-side route. Why is the server interrupting here? Whenever you hit enter on your URL bar or something like that, that is a request, a GET request to a server of this endpoint. So when I wrote /login and hit enter, it's like this is a GET request to the server for /login. So, oh boy, how are we going to circumvent this? Do regular links just work? I don't know. Let's test it out. I'm going to add another folder called components. These are going to be components like building blocks of views. So they're still React components, aka functions at the end of the day, but their purpose is not to be an entire view or screen that you will see, but building blocks like buttons or forms or things like that we can reuse to make pages. Views. Again, it doesn't matter what you call it as long as you know what the difference is. Because technically they're not pages. We're going to make that index.tsx. We're going to make ourselves a navbar. I may switch to something else in the future, like a drawer. I'm much more a fan of drawers when it comes to like bigger, complex apps. Whatever. For now, navbar should be fine. It's not going to be very fancy looking either. Matter of fact, I'm going to go copy one of my components here. Again, I should really make this into a template. I'm going to call this navbar. Navbar. And I want it to be a collection of nothing more than some links that we're going to bring in from React Router DOM, because links are what are going to be replacing our anchor tags from React Router DOM. And there's also a nav link. Again, I'm not going to get into styling and stuff like that in this video. Here, I'm just working on some core logic, setting up our app for routing and some auth stuff, hopefully, if I have time. And I'm going to try and sequester styling stuff into like a singular video, because that's not something that you're going to learn too much from with me anyway. Yes, we'll get to styling at a later point in time. I just want to render a few links. Okay, So these are the React Router DOM replacements of the anchor tag, because again, we're not making requests to different static pages. We're simply asking it to change the URL bar's location and to render the appropriate component on that path. So this is like switching a JavaScript code. You'll notice here that these links will render into the DOM as anchors, but they're anchors with some logic attached to them that behave a little bit differently than a traditional anchor tag does. All links need to have at minimum a to property that takes a object or string value of where they lead to. So we're going to have, surprise, surprise, matching the names of the paths that I made up in my app.tsx. They have to match these paths we have defined here. And from there, I'm going to give them some just like flavor text that I can click on. They're going to be jammed up against each other with nothing separating them. That's fine. I could just add some inline styles here in just a moment. But I want to make sure this nav bar renders. So I'm going to add it here to my export list. Navbar from /navbar component. Thank you. In my app here, what's nifty is that your set of routes dictates paths and elements that render on them. You can very easily just render things around. There we go. Yeah, that's what I'm talking about. I'm going to move these like this. There we go. I didn't have to do that. This is what I like to do with my import statements, right? I have like library stuff up top and then my personal imports separated by a line. I don't know. I can't help it. You know, I'm compulsive about weird things. Doesn't matter what the import order is, right? I just like to keep it somewhat organized. Anyway, what I was trying to say is that you can still render JSX in your browser router, but not directly inside of your routes. Like they don't have to exist there. I could render a nav bar above whatever's going to render below it as a child of the browser router, right? So now that I have that set up, check it out. I'm going to go back to the home page, and that request works just fine. Why does that request work just fine when login doesn't? Remember, we set this up on our server here to do the following, right? By the default request path, it'll send the public folder, which is all this lovely React code that we have attached to that index HTML, which is why it works the way it does. But when we typed in /login, let's test it again to make sure nothing's changed. No cards up my sleeve here, no tricks. Same problem. If I hit enter on the URL bar, it makes a request to the server, and we get a 404 error page. But if I click on a generated link by React Router DOM, those do not actually incur GET requests. So like I said, they render as anchor tags still. If we look here, we can find one really quickly. As you can see, they still render as anchor tags, but they just have some code attached to them that simply changes the URL location, which corresponds to a path, which renders a particular element. So it's the JavaScript logic that's running the changing of the render that we're looking at here, right? So how do we fix this? This is, again, a problem that all of my students in the Full Stack Bootcamp already know how to fix because they run into this problem. It's what happens when you have a mono repo like this, where you have both a server with routes and a client side with its own set of routes. We need to tell our server to how to differentiate those routes. So basically, we need to have some kind of catcher's mitt that says, hey, if this is a client-side route, we're going to let the client handle it and not let ourselves get in the way with my whole global error handling process. That's something we just have to keep in mind when it comes to this stuff. Okay? So we're going to be doing this again on our server. So we're going to, unfortunately, head back to the server TS file where all of our magic tends to happen. And now we need to provide a list of routes that are not going to be used as API or auth routes, but we have to intercept before it gets to the 404 and then eventually global error handling middlewares, right? So in this list here, we need to provide that somehow, right? And in the past, I would show students the cheesy way to do it, which is the following. Res.send file, like this. And that's basically what we'll be doing. We're telling it to send a particular file when it comes to all these routes. We're saying, hey, if it doesn't match with API and auth, we're going to just defer it to the front end and let it figure out what it's trying to do right here, which in their projects from the Full Stack Bootcamp, as they're learning these things, is fine. The asterisk is a wild card. We talked about it a little bit, I think, when it came to adding... Yeah, we talked about it a little bit here, right? The wildcard operator. Basically saying, hey, if it's not matched somewhere in this set of routers and nested routers, then this will catch it and just send the public folder and index HTML file and all the goodies that are attached to it for us without too much fuss. But this is not going to work as a solution in this case, because I want to make sure that if they're client-side routes, they're handled by the client. But if we still pass our server a bad path, that my 404 and eventually global error handler will still kick on. So if you didn't know this, you can provide an array of values as possible paths that match. The / path is already covered by line 17, the public with express static middleware. I'm simply going to add the login and private routes to this GET request. Remember, it's a GET request that we're doing via the URL bar. Realistically, I would probably suggest moving these into maybe some kind of global JSON file that both of our client and our server can read from, or even just a variable that our server uses for now. I'm going to leave them handwritten here, and as I add more and more routes in the future, we'll come back and revisit this and fix it. But for now, we got to do some node stuff. I want it to send a file, and the send file needs to have a directory path that needs to scale, because eventually when I deploy this, my path of like C, Covalence, helping students, DnD, note taker, server, or dist server it's not going to have the same path on my computer as in the deployed version, wherever that server happens to live. So we need to make sure that we're handling absolute pathing correctly. And we're going to do that via the path module from Node, the one that installs with Node for us here, right? So what we're going to say is send a file that's going to be a path.join of our dir name. And we're going to say up1 public index HTML. Now, if you're also wondering here, for my more astute people watching this video, you might be wondering, hey, Luke, but you're inside the server folder, which is inside the source folder, to find the public directory. I like how I change it from folder to directory whenever I want. I mean, I can't help it. So you're thinking, wouldn't that be 2 up directories right there? And the answer is no. That's a great thought, because I also fell into the same trap when I was a newbie. Remember, when our code is actually running with NodeMon, it is the compiled version of the code, not the raw TypeScript code that we've been writing so far. And that is represented by the dist folder, where our server.js file is being compiled, bundled, and outputted to. And so technically, to get out of dist and find public, it is up one directory into public to find it, and that's what the problem there lies. So why are we going through all this trouble when the links work just fine anyway, right? Now if I type /login, well, login is not a path, so that was a good test. The 404 handler is still working, but if I write /login correctly and hit enter, we get our index HTML back in the browser and showing the correct component. Why did I go through all that trouble? Well, realistically, like if I want to share something, like if I wrote a particularly cool note or had a session or something like that had some really cool notes that I wanted to share with my friends, I want to give them a URL that they can paste into their browser and hit enter on and go visit that notes page or view. But that can't happen if I don't write this code on my server. So again, this is a unique problem that is only happening when I have an SPA with routing, client-side routing, running in the same server location as well, a server that has its own set of routes as well. This is a unique problem we have to handle with the way we've coded this project. But it's good to know why that's happening and why we need to do this. So there you go. That's our solution to having that problem. So now we can head back to the front end and keep on goofing around with some stuff here. Hokey dokey artichokey. I'm going to collapse the server. Like, I personally always tell my students to do this, and I tend to do it kind of subconsciously as well, where I will always collapse my server folder and close out my server files when I'm done working inside of them, because I want to keep a clean slate, clean mind to know, hey, I'm on client-side coding now. Don't try importing and doing server-side stuff, right? I want to make sure I'm not accidentally crossing the streams, if it were, in any shape, way, or form, which is why I'm very cognizant about what I'm doing here. Okay, so what is next? Well, we should probably actually get the what's it called? We can get the login component working and actually storing the token. Then I can start worrying about auth, because auth, again, this is not like the way to do stuff. I've been saying along the way, these are choices I've made. They're not necessarily the best choices or things I would do in larger scale projects because, well, you know, you'll typically have like different auth solutions or different auth problems that require more complex solutions in larger scale projects. Since this is a small side project for our portfolios, mine as well as yours, since you're coding along, and this is a tutorial meant for like beginners and intermediates and not like advanced people already, which I don't think are part of this audience anyhow. Like I mentioned, this is not the best solution. This is just a clever one that I like to get up and running with fairly quickly that teaches some cool things along the way. But again, I'll talk about the trade-offs and pitfalls of what we're coding and what you have to do to fix them, which again, typically I'd be like, just go pick up a library that handles it because, well, that's the way it goes with Node, right? But, you know, we're going to write it out by hand because that way we know the features we'd have to add ourselves or what libraries feature-rich libraries that handle like data requests and things like that for React are very feature-rich that we would have to otherwise write ourselves. But I do like writing things myself, like to understand at a fundamental level what's going on and how it works. That way, when I eventually switch or use a library in a different project, I'm much more versed about what's happening behind the scenes and how that library handles what's happening behind the scenes for me, right? So again, it's like, I'm not going to build an entire car, but I am going to go ahead and carve out like 4 wheels, build a chassis, like a basic driving column, and figure out how that kind of works. That way, when I actually go and, you know, buy an advanced vehicle of some kind, I understand how the fundamentals work behind the scenes, right? Now, granted, that's not a great analogy because plenty of us don't know how an internal combustion engine works, but we still drive cars anyway. But don't worry about that, right? It's always good to code things by hand at least once to get a feel for how it goes before you go and jump into a library that handles everything for you automatically, right? With that said, let's go ahead and start with something simple here on our login components. Like I said, I eventually will bring in styling and stuff like that, but for now we're going to keep it fairly simple. Underneath this lovely H1, I'm going to provide another div. We're going to write our form component. We're going to have an input times 2. One is going to be for our email. One is going to be for our password. Okay. They are both going to have, I can't remember all what the attributes are for these inputs that have like, what's it called? That have like a ton of attributes, such as, I'm Googling something on the side monitor. Yeah, I mean, I'm sure, what's it called? I'm sure Chrome will tell me, hey, if you have this type, you should probably do this kind of, like I think there's like autocorrect, autofocus, autocomplete. One thing is autocomplete. It might have been, again, I'm not, this is supposed to be simple, Luke, remember that. Okay, so we have our inputs. We're going to have a button, surprise, surprise, that's going to say button. That'll be our login button. We're going to click on it, attempt to log in, and we're simply going to stick with like console logs for handling errors and things like that. No big deal. So in React, we have 2 ways of wiring up inputs. We can use what are called uncontrolled inputs with refs, or we can do controlled inputs with state. They both have their pros and cons. State-controlled inputs means you could do real-time, like, format checking and whatnot, or, like, real-time, like, as someone is typing their password field in or email field in, it says, hey, you have to write a valid email address in there. That's a really good thing about state-controlled forms. Uncontrolled forms, they just write into the form, and then you use your refs to rip in from the DOM back to React what they've written inside of it. So you can only test or check what they've written after they press the button. But with state-controlled forms, you could be checking things as they're writing it, right? Because, again, that's being puppet-controlled by React. So we're going to go the stateful route. So I'm going to choose to import our lovely useState hook from the React library. And with the rules of hooks, they have to be at the top scope of the components. We're going to have a singular one called values and set values, and we'll call that with useState, and I'm going to provide an object. Now, this object is going to have a type of the following. It's going to be an object who will have a key that will be a string, whose value will be a string. Simple as that. So I know that's kind of like in any object, which is fine, but again, I'm going to do something kind of cool here with this state. So, because I could have one state for the email and one state for the password, I'm going to choose to combine them into one object, which is like one of the first like kind of advanced techniques that you learn in my standalone React course that kind of lead you down the rabbit hole of what reducers are, how to use the use reducer hook, and eventually why Redux was built the way it was, right? Because we can control multiple state values from one object for efficiency's sake, right? That way we can call like a singular set state rather than multiple set states that have to daisy chain together, which could be kind of annoying to deal with sometimes. So how does this magic work, right? Because these things have to have a attribute called value that is tied to a particular string value. Because these inputs are going to be they're going to be taking strings as a value, we have to give it a string value. But as of right now, I have an empty object. Well, eventually this empty object will have a property called email. But as of right now, values.email returns to us undefined, right? Blank object with no properties, .email, undefined. And undefined for a value makes React think that we're doing an uncontrolled ref style input, which we are not. We want it to be a string value that is controlled by the state. So we're going to do what's called a JavaScript short circuit by doing this OR operator to say, hey, if this value is falsy, which undefined is, default to this empty string value. That way we tell React this is going to be a controlled input, and this is going to save us seeing an error in the DOM, right? Because you'll see an error that says, hey, it looks like you're switching from an uncontrolled to a controlled React input. Pick one, dummy. That's what the error tells you without the dummy part. But this circumvents that error, and that's how we're going to handle it. So we're going to have our onChange, because all controlled React inputs have a value and an onChange. We're going to capture the event and just run an inline arrow function here. You know what? No, we can do this as like a utility function. Let's do it that way. Handle changes. It's going to be from an event. Now, TypeScript's not going to know what this event is, so we're going to tell it what this event is. It's going to be a react.change event that is occurring on specifically HTML input elements. Okay? And we're going to put handle changes down here in the onChange. Okay, so we need to call set values, and we have to update the values somehow. So where is the value coming from on control React inputs? It's the event.target.value. So for now, let's just console log that to see what it looks like. e.target.value to make sure that this input is indeed registering that I'm hitting keys in it. So back to the browser, refresh, zoom in, so y'all can actually see what the heck's going on. There's our lovely login. I told y'all Chrome would tell me. What does it need? Input element should have autocomplete attributes, current password, more info on Google's standards. Yeah, we'll go do that. So for autocomplete equals current dash password. Password. There we go. Oh, same thing for, I guess, the other one. So we'll do autocomplete current email, I'm assuming is one. We shall see. Hey, it looks like our errors are gone now. Okay, now back to reality. Let's type in our lovely email field here. And is indeed e.target value is logging which input I'm typing from. Or typing into. How do I know which input it's typing from? We're going to utilize another DOM property here. We're going to utilize the name property or attribute of inputs, and we're going to write email, and that will come from e.target.name, comma, e.target.value. Let's log which input we're typing into and what value we're typing into said input. So now, refresh, here's what it looks like. Hey, it recognizes we're typing into the email input. Why is that going to be important? Well, because here in just a moment, I'm going to add the same value in onChange attributes to my password input. Format the document. Add the name attribute into password. And it'll be values.password or empty string in this case until we actually update our state. So let's see what happens now. Wow, for email. 1, 2, 3 for password. Now we still have an updated state. So even though we're typing and JavaScript, aka React DOM or the React, is recognizing we're typing into those fields and even console logging them on the onChange handler, we haven't told React to update the state, which will then trigger the DOM to re-render to show what they've been typing into the inputs, right? This is the first thing that typically blows students' minds, going, why do I have to go through all these hoops to actually get there? Because React is just a big old series of, like a giant nested mess of objects that we're actually updating properties on that then get rendered into the DOM to what a user sees. So while they're typing here, it's actually React behind the scenes, listening to what they're typing and telling the DOM to update to what they're typing, right? So to do that, we have to actually update state, because state changes means re-renders. So How are we going to do that? We need to tell this object, hey, a new property called email is being typed and here's its value. Or for example, here's a property called password and its value. What we're going to do that is we're going to call set values. And I'm going to stick to the console log because, again, here's what we're going to do. I needed to tell it that there's an object that has this as a property with this as a value. And to do that, we can do exactly what we did up here for the type is by using the square bracket notation for properties. Okay? So what we're going to do is we're going to tell this object to update by adding this as a property or finding that property if it already exists and updating its value to reflect what they're typing, aka e.target.value. Okay? And this was represented by basically the following code. We're going to say this is going to be a set of square brackets as the property name, colons for objects. Stop, the highlight was messing me up. And that's going to be the object structure we're looking at here. So, hey, get an object, find this property or add it, and then add this as its value or update that as its value. So what that looks like now is our email. There you go. It's not adding up, I know, it's fine. But that's generally the idea we're going for here, right? Making an object with that property. So to actually update the state now, here's how we're going to do it. Set values. Now, the update state or set state function that comes returned from useState, by the way, this set values variable I've made up, it has two different ways of updating state. It has a direct way where I just set that object like this. We're going to remove this console log, right? I can directly tell it, hey, this is what your new state looks like. And React's very good in that it will figure out how to mesh the two together. But you want to be careful with things falling out of sync. So there's actually a callback style version of setState that makes sure that we don't have any issues with asynchronous code and closures. And we use closures to ensure that it snapshots the correct state values. So when you're updating multiple states, we cannot guarantee that React is going to update them in the order we wrote them because they are all asynchronous, and React behind the scenes will actually bash them together for efficiency's sake, which means if one set state has to update another, they will not necessarily work the way you think they do. Again, my React course goes over this in painstaking detail. So I like to do this syntax here to where I make sure I say, get me the previous state of this setter function, aka values. Get me that previous state to make sure I have it captured correctly at this time and place. And I'd like for you to then, we can write return a new object that maintains every property in the previous object state and will target or add this property with this value. And with some shorthand syntax, we can ditch the keyword return, ditch the curly braces after the arrow function, wrap this in an implicit return via parentheses, and that's how you get this little bit of code right here, right? So we did some ES6 shorthands. We can do an implicit multi-line return by dropping the return keyword, dropping the curly braces, and using a set of parentheses instead. And the pink parentheses we're looking at here are the object that this thing represents right here as we update our state. So now with this in place, let's go ahead and bring up my component dev tools. I'm going to refresh the browser here. We're going to find it in the dev tools with the login router. There is my hook right there. And there you go. Yeah, so that's a really cool way to wire up any form. And if you're wondering, could we create our own custom hook, maybe called useForm, that sets this up and does like a couple other functions like reset and maybe even some sanitization of values if necessary? And the answer is yes, we totally could. And we probably will in this video. Then eventually I'll get fed up writing my own features onto the custom form hook and then switch to a third-party library that does it all way better than I ever could. This is the classic, right? Okay, so we got this lovely bit of code now up and running, no problem. It is time to wire up the button for logging in, as well as possibly combining it with the form submit to make sure that if someone hits enter on their keyboard, it counts as a form submit and they don't have to only click the button, something I always forget to do in my projects. For now, let's start with the button. Const handle click is going to capture an event that will be a React mouse event occurring specifically on an HTML button element. And within here, we want to make sure that the form does not do its default behavior. Now, if you click a button inside of a form, as we are looking at right now, it'll actually refresh the page. Let's go ahead and see this. Console log test. Handle click will be the onClick function for the onClick handler, or attribute right there for the button. Let's go see what happens. Type some stuff in. Blah, 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 blah. Login. This is Chrome sanitizing the input for me because I wrote it as a type equals email. There we go. Let's try that again. And you see the form cleared out, the console log appeared, and then disappeared pretty much instantaneously. This is because the default behavior of a form in the browser when you click the button is to submit the form, which is some kind of action and method sent to a server, right? So it's like, okay, I'll submit the form and then I'll wait for a response from the server. But we don't want that to happen because once we refresh the browser, React is going to lose all of the juicy state changes our user had been making up until that point. It refreshes and goes back to its default state, which is a blank form with blank inputs ready to log in. And if there's any code that was running, we've lost it because the browser refreshed. So to stop that, we're going to do the classic conundrum fixer of e.prevent default to make sure the browser no longer refreshes. Put back that console log. I don't know why I deleted it. Again, it's proving y'all a point here. What at email.com, log in, and everything stays, right? So, looking Gucci. Feeling good here, folks. Now we need to actually make this a post request. So to do that, we are going to convert this into an async function so we can start using, because I've been using async await in the back end. And honestly, when it comes to logic over here, I actually prefer .then syntax. I know I'm a freaking weirdo for that. I don't know why I prefer .then on the client side, but async await on back end. We'll stick with .then on the front end for now. We're gonna practice another way of writing code, right? That's the fun part about it. So what this needs to do is it needs to make a login request to our server, which if you recall, let's go take a look at it. Auth login. The login endpoint is localhost 3000 /auth /login. The method is post. It sends a request body of type JSON that has at least an email and password of the following values, test, and it responds with an object of property token with that JWT token for us, right? So here we go. We have to basically recreate this login request via a fetch request. So let's go do it. We're going to make a fetch request to the following endpoint. Now, because my server and my website are running on the same port and location, I do not have to write localhost :3000 /auth /login. This will take the root. This request will go ahead and take the root URL and add it at the beginning for me, so I can get away with just writing the relative /auth /login. It'll add the localhost :3000 for me since the server and client website are running in the same port. Okay. Now, I need to provide some additional options, configuration options to this fetch request. So that's a second object to our fetch request, specifically adding a post method to this. Fetch request by default will go with get requests. By the way, fetch is built into most modern browsers. We're going to go to caniuse.com and type in fetch. Yeah, Internet Explorer, that's no surprise. But it looks like fetch is available in all modern browsers. It has an adoption rate globally of over 96, almost 97%. That's pretty dang good. Fetch is basically the replacement of jQuery's AJAX function. It's the modern replacement of the old XML HTTP request functions and stuff like that. I like it. I would probably use a fetching library if I was doing like a hackathon or building a real project that's going to have real users on it and not just for a portfolio. I would use some kind of data fetching library that meshes well with React as well to handle all of my edge cases and cancels and whatnot and abort controllers. But for now, we're going to keep it simple with just vanilla fetch requests, which are going to be making requests to our server. Again, basically pantomiming what this tab is doing for us. All right, so that's our endpoint. That's our URL. That's our method. Now we need to tell it that, hey, we're going to have a JSON body coming along with this fetch request. we're recreating the headers that this post request has done for us. And in particular, headers is going to be another sub-object, surprise, surprise, that's going to have a key of content-type of a value of application/JSON. How do I know this? I've done this a million times. This is why I know this. You would have to go look up how to write fetch requests with custom headers and just look up their keys and values, which can also be found here, for example. So content type application/JSON is what we're adding to our request headers. Why are we having to do this? Well, again, fetch requests don't by default have a JSON body attached to them. They can be of different kinds of request bodies being sent to any given server as a request. Our server in particular has one right here called express.json as a body parser. How does this body parser know to intercept a request and parse out its JSON body? Because it has the headers for it. It finds content type application JSON and kicks on and does its job. Okay, so from there, we can now finally add our body to this request. It needs to send JSON data, so we need to do a JSON.stringify of some data. What data are we sending? Well, we need to send a request body that has what? An object of property email and password in JSON format. JSON stringifier is going to handle the formatting. What does that object look like, folks? The state we've been controlling so far. So I'm going to tell it to get those values, stringify them, and send this request off. Now, fetch requests, if they fail, do not work the way you think they would work. If I log what the error message is if this request failed, like a 401, for example, or 404 not found if I write to logins, let's go see what happens, because this is something else you have to learn about fetch and why I think a lot of people don't end up liking it and end up using libraries instead, such as Axios is a very common one. That's just a simpler version of fetch, I guess, or behaves like more you'd expect. You know, it's going to get really annoying writing the username and password in there every single time, isn't it? So watch this. Here's what we're going to do. We're going to cheese this a little bit by making our initial state the correct login values. That way I don't have to write them out every single time I'm trying to test them. That'll get very annoying very quick. There we go. Now I can test my logins quickly. So we wrote the .catch, meaning we're expecting to see a console log appear with a square bracketed error and the error message rather than the full error object, because this is a 404 not found problem. So we got the error, meaning the browser recognized that the HTTP request we just made had an error in it that we need to look into. But this is not the error that I wrote, not the console log error that I wrote in my .catch, is it? Why is that the case? Well, fetch doesn't treat bad status codes as errors to be thrown. So we have to handle them ourselves. So we're going to head into the then, and we're going to capture the response from the server and log what it is to see what the heck is going on here, right? We've got a response from the server. It's a bad one, so why isn't it throwing it to our catcher? Okay, so guess what? The way fetch treats this, it goes, hey, I got a response. There you go. The fetch is like, that's not an error. I got a response from the server, which means I did my job correctly. So it's up to us to determine the error handling of fetch requests, right? Unlike Axios, which it would send the status code to our catch as an error. But in fetch, it doesn't do that. So we have some properties we can use. For example, .status could tell us what the status code is. If it's in the 400 and 500 range, that's just throw an error. There's also this property called .ok, which is a Boolean value. On 400s and 500 range values, it will throw false. If it is a 200 or 300 status code, it will be true. We can utilize this property to our advantage to properly handle errors. So we can say if res is not okay, it's a bad request, we can ask it to stop here and simply throw a new error. That could be request failed or something like that. This actually won't help us too much in terms of error handling. Oh, I don't need to write return if I throw a new error, right? And let's see what this does for us now. So we got our error handle, and again, like this is not very useful information for logging purposes. This is way better to tell me what's going on here. So what does this do for us? It will allow us to use the error catcher to maybe launch a toast or a modal or a redirect. Not so much for logging the error, but this is really good for UX or user experience in terms of navigating modal pop-ups and things that appear that tells our user something went wrong. Contact a system admin, or you must be logged in to view this page. Like that's how I utilize these errors with my fetch requests, for example. So that's something to keep in mind. But we also know from my server that it's giving us a JSON response anyway. So we could always parse that JSON response and pass it to a new error and throw it that way. Just wanted to point out that this is how fetch works and something you have to keep in mind. Okay. Let's say the response is okay. We're going to take the response and take its JSON and return, or rather take the response and run a JSON function, which is a promise to parse the body response of our server. And then that is a promise. We can then daisy chain the .then on the outside, since we're returning this promise from within this .then function, to say whatever our message happens to be or response object. We can call it res again. Doesn't really matter what we call it. And let's console log that res to see what's going on. Okie dokie. Refresh, login. Oh, it throw the error, Luke, dummy. Let's comment that out. I was like, why didn't it do what I wanted it to do? Because it was still throwing the error. There we go. And look at that. That is the error we're used to seeing from our server. The method and the path were not found. That's our error being thrown from the server right there, right? That's because we parsed that JSON response that our server is coded to always respond with, which is why we went to the painstaking lengths of those passport custom callbacks and stuff to make sure that everything is being handled as JSON values, right? So we could always, no matter what, parse the JSON body, but if the res is not okay, parse it and throw the JSON body error message as the error message to log or something like that. Just food for thought. But we're going to cheese it here and keep it kind of simple. There we go. And keep it this way. Let's actually go fix the login request and make it successful. And let's see what ends up logging on this login attempt with the correct input values is a token, which means theoretically, if we store this somewhere, whether it's in code or otherwise, like, I don't know, even something as simple as this, blank, and upon login, we can say token equals, and it's token, so it's res.token equals res.token, and voila, we now have a variable that it's stored into, technically in the global scope of my application. Typically, you don't use variables like these outside of your components because they can be overridden by accident, and if I had multiple renders of the login component, they would all be referencing one token variable. This is not a unique variable per React component. So this technique of using a global variable outside of the component's code itself or component scope is actually fine when you're dealing with what are called singletons. Singletons are components that are rendered one time and never again. Again, my React course covers this kind of terminology and use cases, which would be fine. I mean, once they refresh the browser, they're going to have to log in again, though, so we know that's not exactly the best solution. So in our case, we're going to keep it simple. To simulate a login, again, this is not the way I would do it in more complex applications. There are problems with both cookies and local storage, but we're going to be using a browser's local storage. Unlike session storage, local storage will be remembered for a specific location, aka localhost 3000 or mycoolwebsite.com. I can close tabs and reopen them, and it will persist values in local storage. Local storage works off of key values and pairs. We're going to have a function called setItem. We're going to give it a value of token or a key of token, and our value will be whatever the token that came back from the server's response is going to be. We're simply going to set that to state or set that in local storage and retrieve it and call it a day from there. So let's check it out. Log in. Nothing seemed to happen. If I hit local storage, if I hit local storage, thank you. Looks like I've been goofing off with other stuff here in the past. So I probably should have cleared local storage first. So that was like from previous project I've been working on. So let's try that again. Nothing up my sleeves, folks. I promise. I promise nothing up my sleeves. Right now, nothing in local storage. I click login. Local storage has my token inside of it. So theoretically now, as far as website is concerned, it thinks I'm logged in. Now, from here, the cheesy and very newbie way to handle it would be to say, hey, if there's a token in storage, let's just let them view this page because theoretically they're logged in. That's a naive approach because theoretically this token could be tampered with. It could have an invalid signature. It could have expiration on it, for example, right? It could be expired, so we should test it in some way or form to make sure that it is a valid token before moving forward. That's two different ways of approaching the problem, right? Just assuming it's good to go, and then ultimately if a request fails, then we'll know it's bad, or we can write some logic that says, hey, when we go to certain pages, it checks the validity of the token, and surprise, surprise, we have a route to do that for validating a token. This video is already an hour long, so I'm going to call it here, but this is a really good stopping point. We've gotten a lot done on the React side of things. We've already talked about how we're going to start setting up auth and whatnot. In the next video, I'm actually going to code out the private component that's going to handle our logic here. I'm going to talk about how we're going to be using some advanced React features such as context. I'm going to throw that one in this video, and custom hooks to generate some really cool code for when it comes to handling auth in our project. But for now, I'm going to do one more additional step, which is coming out here because I'm tired of seeing this error on our component dev tools. In development, React gives you a tool to help find problems in state changes and renders that has no footprint or output at all in production. This is a development-only tool that you don't have to worry about removing before deploying. And it is called React Strict Mode. What we're going to do is wrap our app in a strict mode tag. What this does is it forces our components to re-render twice for every single state change. So we're going to notice now if I console log any kind of state changes, we can go take a look at that up here. I'm going to laugh if it doesn't work the way I think it does, or if they changed it recently. Right, lol for state changes, refresh, go type into my components. Of course it's logging once. It might not do that for these kinds of, for like input-based state changes, but what strict mode should do, I refresh the application, right? Yeah. Go figure. I know what it's supposed to do is it's supposed to make things render more than once so it could help you debug rendering state change problems when it comes in development. That way you don't have to go, wait a minute, why is this thing rendering twice? It's because our strict mode is activated. But I think I'm annoyed that it doesn't work the way I think it does. Because I thought I'd be seeing double logs of lol, but it's not. Either way, that gets rid of that pesky error there, and that's theoretically what it should be doing. I can probably show it to you guys with the use effect instead, because that's where we might be noticing it from that particular hook. But either way, for now, we're going to add that on there and just know that it has no output. We don't have to worry about removing it when it comes to deployment time. It's just a tool they gave to us in the newest versions of React to help us debug our React applications more easily. So yeah, we're going to end this one on an L, surprisingly. Like, comment, subscribe, find the description below, go to Covalence if you're interested in my React standalone course, and I'll see you all in the next video where we cover more auth stuff.